Okay, folks, this is Sunday, May the 24th, Memorial Day weekend, and I hope you're taking the time to remember what Memorial Day is all about. Not about the barbecues. It's not about the family get-togethers. It's about those we lost. My brothers and sisters I lost. My nephew I lost. Now let's remember that. I'm taking this day to do some help for you all in the rigging hardware and rigging sections. It's the time out of my time. I hope I help you out. To honor the time that I'm taking for you, will you please do me a huge favor? Like and subscribe. I'm doing this extra stuff for you. This is for free. I don't do this and get paid for it. The Heavy Equipment Colleges of America could give a rat's ass if I do this for you or not. But I ask you, please do me a favor, like and subscribe. Thank you. All right, so here we are going into rigging hardware. Rigging hardware includes shackles, turnbuckles, eyebolts, eye nuts, swivel hoist strings, wire rope clips, wedge sockets, anything that will connect a sling or a hook to the hook to make a lift. Overhead lift, crane lift, those type of things. So, as we talk about these, you need to know absolutely 100% that the Shackle up to 150 tons has a design factor of 5. Shackles over 150 tons, heavy design factor of 4. So 151 tons is a design factor of 4. Design factor, ratio between the design breaking point and the working load limit. Can't believe I have to keep saying that, but I hope that you hear it. Turnbuckles, eyebolts, eye nuts. If you look to the back of the room and see all the rigging you've been working on doing the scenarios for Rigging 1 Practical, those are all design factors of 5. We don't have anything on that back table that has a design factor of 4. So if you see it on the back table, now you know what the design factor is for those items. Now you can remember it for when you take your test. We don't have a load indicating device back there. We don't have a rigging block back there. We have, obviously, do not have a wedge socket and wire rope clips back there on that table to do your rigging practical. We do have all of the shackles, turnbuckles, eyebolts, swivel hoist strings, master links. Please remember, that's an easy way to remember all this. Anything sitting on the back table has a design factor of 5. All right, moving on. Rigging hardware. What's going to be on the shackle? Well, you're going to have the name, who made it, rated load, working load limit, and its size, and some type of indicator of what it's made out of. On the pin, you're going to have some kind of designator or trademark for the manufacturer and what it's made of. No size, no serial number on the pin. Remember, shackles are sized by the bow diameter. The bow diameter. These sections, that is called the bow diameter. The pin is sized by the bow diameter. You know, with me, if I repeated it, it's something you need to know. All right. The hole in a shackle pin is there for mousing it out. You put a piece of wire or zip tie or string to pull it in a tightening direction so it will not work loose, especially when lifting people. We talked about the pin, what it has on it. Turnbuckles, eye bolts, eye nuts, they're all going to have who made them, their working, load limit, rated load, torque value. Remember, torque value for them is set by the manufacturer. Wire rope clips, who made them, their size. Wedge sockets, who made them, the rated load, some kind of model number. Links, swivel hoist strings, who made them, size, rated load, grade, and working load limit. Rigging blocks, snatch blocks, who made them, rated load, and the rope that will go around it. Whether it be a 6-to-1 ratio, D&D ratio, diameter of the object as compared to the diameter of what's going around it, 6-to-1, 6-inch to 1-inch rope, that kind of thing. That'll be on there. All right, load indicating devices. Who made it? Rated load, serial number, model number, and any type of controls. A load indicating device is a fish scale. Think of it like that. You need to get a preliminary weight of the load. Remember, not all rigging is done at the crane. Sometimes a load will be rigged and brought out. Just think of it like that. They have to know the weight of the load so they can determine center of gravity and that kind of thing. Rings and swivels, master links, who made it, rated load, grade, that kind of rigging blocks we talked about. I'm sorry, I went backwards. All right, rigging hardware usage. You shall protect it from sharp edges, softeners. You shall avoid shock loading. You shall make sure it's in good working order. You shall make sure that the pin is not ground down. It's not stretched or elongated. That the pin, the shoulder of the pin fully engages all the way around the ear. Rigging hardware should not be used above 400 degrees to a -40. Installation of shackles. You shall not install the pin and back it off a corner turn. You shall not back off that pin. The load shall be centered on the bow as best as possible. You shall not put 2 sling eyes on a pin. The included angle on a master link or shackle shall not exceed 120 degrees. Anything greater 120 indicates that the horizontal sling angles at the bottom of that load there go lower than 30. And anything at 30 and below must have a qualified person consulted. Master links, shackles, included angle not to exceed 120. Hooks, included angle not to exceed 90. You better know that. Do not rig it in such a manner as to that the pin may potentially work loose. You see the top image there. The direction of the sling rolls across the pin. It could potentially work the pin loose. Shackle pin installation on a choke. You've been doing this right along when you've been practicing for your slings and hitches for the practical. The pin rides on the standing end or the eye. The rope the sling that goes to the hook is called the running end. You shall attach the pin to the choking eye of the sling, riding on the eye. Shackle pins are sized by the bow, not the pin. You shall not intentionally side load a shackle without reducing its rated load. So if you side load it at a 90 degrees, you're almost 75, almost to 100% capacity reduction because you're pulling on that ear. 45 degrees, suitable. Try to center it as best as possible between 0 and 5. That way you're getting no capacity reductions or little capacity reductions. Turnbuckles, just like wrestling. You turn the body to tighten them. The fittings shall be fully engaged. And they tighten, they add tension to rope. They're just like I said, wrestling. Turnbuckles, they add tension to the ring's ropes. Do not intentionally side load a turnbuckle. They should be lifted 0 to 5 degrees of vertical if you're using them. When you tighten, you turn the body, as I mentioned. Okay, eye bolts, just like you've been doing right along for your practical practice. The shouldered eye bolt is used for angular lifting. The unshouldered eye bolt is only used from a 0 to 5 degrees of vertical. I say again, shouldered eye bolts, angular lifting. You shall put them in the plane of the load or in the direction of the load. CCO test questions right along as I'm telling you. If you're installing them in a blind hole, you drill the hole and you're putting them in that blind hole, you shall have it 1.5 times deeper than the diameter of the bolt. And that's to prevent it from pulling back out. The shouldered eye bolt, angular lifting only. Please remember this. 1.5 times the diameter, it shall be deeper. When used, the nut shall be fully engaged. You shall have a washer between the nut and the load, in the direction of the load, in the plane of the load. You know, I keep repeating these things because it's important. Eye bolts shall be flush and tightened. I said this already, in the line or in the plane of the load already. And you shall only use shouldered eye bolts when lifting in angular operations. Swivel hoist rings are determined by the torque value of the manufacturer. If they're in a blind hole situation, it shall be 1.5 times deeper than the diameter of the bolt. Fully engaged, torque value, you never put a washer or a spacer between the bushing and the load. But you always put one between the nut and the load. Torque to manufacturer specs, I already said. Do not exceed the working load limits of the swivel hoist rings. Do not exceed the angular rigging tension. So, again, 45 degrees is 1.414. You don't rig it below 30 degrees without consulting a qualified person. Wire rope clips. You shall not use wire rope clips to make slings in overhead lifting. You shall not drag them across the ground. You shall install the saddle on the live end. Never saddle a dead horse. You will notice the U-bolt, the red portion of this, is on the dead end. The saddle rides on the live end. Who determines the length of the dead end? The manufacturer. Here it is, the saddle, the U-bolt. Never saddle a dead horse. Number of clips required. You are going to need to know how to read the rigging reference booklet. They're going to ask you questions directly from the booklet. Anywhere from 25 to 30 questions come directly from the book. All you got to do is flip the pages. Find the answers. They may ask you, how many wire rope clips is required for 7/8 wire rope? Here, 4 turn back 19 inches and torque value 225 foot-pounds. Read it right from the rigging reference booklet. Torque to manufacturer specs, I already said. The spacing and turn back is determined by the manufacturer qualified person. All right, you better know this picture here. You better know why these are incorrect. One of them has the dead end on the live side, and the other one is not in line with the becket. The live line is not in line with the becket. It goes and it's angled straight up, and the wedge socket would not hold. That is why those two are wrong. You shall not interchange wedge sockets with their bodies. You're not allowed to interchange. They are a matched set. Told you about the dead ends determined by the manufacturer. Told you about the do not saddle a dead horse. The maximum included angle on a master link is 120 degrees. Do not drag a master link or across the ground. You shall not use a horizontal sling of less than 30 without consulting a qualified person. Swivels and swivel nuts, don't stress so much about. If you know how to do a swivel hoist ring, a swivel nut's basically the same thing. 6-to-1 sheave pitch diameter for a rigging block or a snatch block. 6-to-1. Don't ride a snatch block up. You shall not exceed the working load limit of a snatch block. You see I'm skipping a lot here because a lot of this, especially with fair lead loading, will be taken care of when you cover with rigging 2. Excuse me. All right. Detachable load indicating devices, those fitch scales. You shall put them in the center line of the load and its tension. All right, hooks. This is going to be real easy. This is covering hooks. You shall know that the hole in a duplex or sister hook is for the pin of a shackle for 1 sling. I say again, what's the hole for? The pin. That's called a duplex or sister hook. The load on a duplex or sister hook shall be balanced. If it has a latch, it shall be fastened. It shall be able to be shut. The sorting hook. The sorting hook is used to lift pipe. The self-closing automatically shuts itself with spring tension. The crane hook flops back. The duplex or sister hook or ram's head, the hole is used for a pin. And then you load the hook evenly. 1 sling hanging from the shackle on a duplex hook. We already talked about identification requirements. Everything will be where we put the markings on a hook is in the non-wearing areas. You're going to have its working load limit, who made it, the material it's made out of, and it's going to be in the low stress or non-wearing areas of the hook. And if you're going to use a hook, it better be equal to or greater than the working load limit of the other items that you're rigging. It better be suitable to hold the weight of the load. Normal inspections of a hook, your pre-operational shift inspection done by a competent person. Every shift prior to use. You can inspect 0, 5, 10, 0% twist, 5% throat opening not to exceed 1/4 inch, 10% wear in the saddle. Anything greater than those, out of service. If you find them out of service, nobody can return it back into service unless it's been inspected and repaired by a qualified person. The yearly inspection is completed by a qualified person. That is the manufacturer or designated inspector. That is not you. I don't care if you think you're a qualified rigger. You are not a qualified person to perform an yearly inspection. They have non-destructive inspection means. They have x-rays. They have a lot of different means of inspecting to make sure there's no cracks and deterioration of all your rigging. Now, you can do a yearly inspection more often based on the severity of its job use, the working area, personal experience. You shall perform if they do a periodic inspection, a yearly inspection, it shall be documented. I talked to you about the 0510 already. You shall not point load or back load or side load your hooks, they shall be in line with the load. You shall not point load or put your sling on the point of the hook. It shall be centered in the bow or in the saddle. You don't rest the load on the latch. The included angle on a hook shall not exceed 90 degrees. Only 2 sling eyes on a hook. And if you're using wire rope slings, the width of the eye shall not exceed the width of the object placed into the eye shall not exceed a half the length of the wire rope sling. And if you're using a synthetic, it shall not exceed a third of the width of the sling. You better know those. I told you about the point, the pin. It's for the attachment point for a pin of the shackle. The load shall be balanced. Locking it out, sufficiently moused. Sometimes a latch will break. You can sufficiently mouse it out so the load will not come off the hook. You better have it on order and get it repaired, but you can mouse it out if the latch is broken. Now, when you're lifting people, all hooks, all shackles shall be moused out or locked out with a nut or a cotter pin or a string or a zip tie to mouse it out. It needs to be locked when lifting people. You shall not put more than 1 sling eye on a hook. More than 2 on a hook, not to exceed 90 degrees. Below the hook lifting devices. This is easy enough. What's on the tag? Who made it? If it has hydraulic pressure going through it, if it has electricity, if it has air pressure, all of those things will be on the tag. Its working load limit, its serial number, who made it, all of those things will be on the tag. If the lifter weighs 100 pounds or greater, its weight shall be on the tag. I say again, if it weighs 100 pounds or greater, its weight shall be on the tag. Like I said, all of these already rated if it has voltage, if it has pressure, if it has hydraulic, it will be on the tag. Suction pressure, it will all be on the tag. All of these are the same. You inspect prior to use. It has a periodic inspection every year. Your frequent inspections done prior to operation, prior to use, and that's done by a competent person. The periodic is done by a qualified person. You shall not load a below the hook lifting device to exceed its working load limit. It's all common sense. You don't load them and ride them up. You don't have them hit an obstruction. You should avoid carrying it over people. Clamps. These are I-beam clamps. These are clamps that fit around the edges of I-beams. They shall be installed perpendicular or 90 degrees to the flange. These lift up beams. You shall not load them excessive their working load limit. All right. If you find a clamp or below the hook lifting device bad, you take it out of service. You tag it out. You do it. Don't leave it for somebody else to take it out of service. Then they forget and you forgot. You do it. You take it out of service. Broken teeth, broken rubber teeth, broken off hooks. They all take out of service. I told you this already. At 90 degrees of the flange, if they require an angle you will use a clamp designed for that type of angle, straight up and down, 45. There are plate clamps that will rotate a load from the horizontal to the vertical. You will use the appropriate clamp to perform the particular duty. These are beam clamps again. These are plate clamps, horizontal plate clamps, just lifting steel plates. Miscellaneous hardware. This is where I have to insult your intelligence and tell you how to use a jack. When jacking your load, you shall place hard wood between the jack and the load. Again, when you're jacking your load, you better have hardwood. You put your hardwood between the jack and the load. Then you shall have sufficient supporting underneath the jack, just like you when you put it underneath an outrigger, so it does not sink. It shall be level. The ground shall be level. You shall place hard wood between the jack and the load. Again, I keep repeating it because it's on there. You shall not use a cheater bar to overexert the handle of a jack. You shall only jack the load to its recommended value. Obviously, these are reasons why we would take out of service. No unauthorized welding, pitted, corroded, broken teeth, hydraulic leaks, mechanical teeth broken, the pawl gear, P-A-W-L, broken off where it doesn't prevent the gear from moving. Pawl, P-A-W-L, pawl, prevents gears from moving. Here's that. You shall place hard wood. You shall have hard wood. When jacking your load, you shall jack them up evenly. All sides shall go up evenly. If you're storing your jacked load overnight, you shall put supports under it. You shall not use your jacks as a long time storage option. You shall put blocking or cribbing under the load and remove the jacks or support it. You shall have a sturdy base, hard wood. Now, don't overload the jack by using a cheater bar, I already said. Don't leave it unattended. Use blocking or cribbing underneath it for long term. Load binders. Yes, I know some of you guys have used load binders in trucking and have used cheater bars to over torque the handle down. Again, I'm only telling you what CCO wants you to know. Do not use a cheater bar on the handle to over tighten it down. Yes, I know what you do in the trucking world. Again, do not do it for the CCO written exam. You can use a pry bar under the handle to break it loose, but you should push upward and away from your damn face so you don't break your teeth. Do not use them because they recommend it against the over-tensioning of the load binder. All right. Upward with an open palm so you don't and smash your knuckles or your teeth. Never use a pipe or a cheater bar to tighten them down. Yes, again, I keep saying this. I know what you do in the real world. I'm just telling you how to pass this test. Lifting beams. Lifting beams are there to lift long objects. You're going to have the rated capacity on the beam, its serial number, who made it, its weight. Now, we don't care about how long the beam is. We do care how much it weighs, its working load limit, who made it, its serial number, but we do not care how long it is. You shall not use less than 30 degrees. without consulting a qualified person. Double the tension. Horizontal sling, double the tension at 30. All right. Rollers. You guys may have all worked maybe at Home Depot or Lowe's. Think of a lower roller as like a pallet jack. You go uphill, you go downhill with those rollers on a pallet jack. You shall have a restraint system at all times, either going uphill or going downhill. You shall have a restraint system that is approved by a qualified person. You don't ride the rollers up and down. Again, the restraint system shall be approved by a qualified person. You shall use it going uphill or going downhill. Already talked to you about this. Qualified person, proper restraint, all times. Okay, this picture is on there. When putting rope on a drum from a spool, you never go bottom to top, top to bottom. You're basically introducing fairly loading or horizontal sling angle and tension. You shall go top, top, bottom, bottom. Never bottom, top, top, bottom. This diagram is whole 100% on the test. Make sure you understand how to load wire rope onto a drum. And the rope shall be in line with the drum. If you're, think of it like this. You're pulling a car, you went four-wheeling, and you're pulling your Jeep back out of with a winch. You need to try to have your winch as close to in center of the vehicle as possible, not to the side. If you pull from the side, you will damage and destroy your teeth on your winch and your come-along. You need to have it straight across. Same thing for loading a drum, your winch drum or your crane drum. This is the same way we load drums on cranes. Top, top, or bottom, bottom. Never bottom, top, top, bottom. Overhead hoisting. Guys, all of this is really basic. It's the same crap. All it is now you're using overhead hoist instead of a crane. You inspect the chains. You inspect the hook. They all have the same inspection requirements. You're not allowed to ride a hook up. You're not allowed to use the chain fall, the extra chain, to wrap around the load. You cannot. You have to use the hook and the chain attached. You see I'm skipping because it is all the same. A ratchet hoist, aka come-alongs. I already told you, make sure they're in line with the load. Never at an angle, never use an extension. Okay. All right. You are the competent person. You shall perform and find the hazard and correct a hazard. You shall correct a hazard by removing it from service. The qualified person is there to do the yearly inspection. It's also the qualified rigger. A qualified rigger shall rig the load when you're doing an assembly and disassembly. So you pick the right rigging material for the job. We don't, as a rule, like to use chains on a lattice boom section or a tower crane section. Synthetics, that kind of thing. A qualified rigger shall be involved. Qualified person, like I said, by virtue of formal training or certification. During an assembly and disassembly, you shall not exceed working load limits. You shall pick the right tool for the right job. You shall use the appropriate pick points. A qualified person will be involved. A qualified rigger. A qualified A&D director who is both competent and qualified will appoint a qualified rigger to be involved. I said this already. Qualified rigger. You shall use padding or softeners. You shall keep clear of the load. Lifting people. You shall close and lock all hooks. All hooks shall be closed and locked, either moused out, chained cotter pin, nut and bolt, but they shall be locked when lifting people. They all shall be of the alloy variety, no synthetics. If you're using a wire rope bridle, it shall have a thimble in the eye, a thimble. You shall have a master link or shackle between the mounting lugs on the man basket, the personnel basket, and the sling you're using and the hook. You better have a master link and shackle between the sling hook, and the lifting basket. If you're welding on a load, the load shall be grounded. The man basket shall be grounded. The welder shall be grounded. And you shall have a fusible link between the load and the hook. A fusible link is just that, a hook with a fuse in it. It's your welding on. It shall have a tagline to prevent the hazardous movement of the load. And I already said this about personnel platforms. Bridle leg must be connected to master link or shackle. You shall have a master link or shackle between each mounting point of the lifting platform. What's on the platform? Who made it? Its working load limit. Its serial number. A hand signal chart. A grab rail that goes 100% all the way around. A door that shall not open outward. All rigging used in a personnel lift shall be 5 times greater than its intended load. We do not make, as a rule, rotation-resistant slings. So the 10 times greater really does not apply. We do not make slings out of rotation-resistant and use them in personnel lift anyway. The rigging used in lifting people shall not have been used for any other purpose other than for lifting people. You will have a toolbox, a rigging box that is labeled personnel lift only. You will not take material out of that and use it in live lifting materials. Only for people. You will not use synthetics. You will use a tagline to prevent the hazardous movement of the lifting basket. That is made out of polypropylene. The platform shall be able to hold 125% of the platform's rated capacity. So you're going to proof test. You're going to pick it up. They're going to hold it for 5 minutes. They're going to perform the trial lift at all boom angles, at all boom lengths, at all locations. You're not allowed to travel with people on a mobile crane. The only time you may travel with a lifting basket is if the crane is on rails and the rails can be locked. You can do your proof test concurrently with your trial lift, but you got to hold it off the ground for at least 5 minutes. It comes back and it's inspected by a competent person. A competent person. Repairs are made or adjustments are made, and then it has to go and be done all over again. Lifting people is no joke. It takes a long time. Here it is. The competent person inspects and removes from service, fixes it, and then adjusts it, and then it gets done. The trial lift goes again. You're only allowed to lift 5 people to 10 degrees of off level. The equipment used in the rigging, the crane, shall be 1 degree of level. But the lifting basket can be 10 degrees out of level because not everybody weighs the same. And you also may be carrying machinery or tools up with them. All right. Okay. I said this already about the 5 to 1. 5 times greater than the intended load. So 5 times design factor, safety factor of the 5 to 1. All right. Remember the crane. The crane used in a personnel lift is derated 50% right off the bat. We cannot exceed 50% of the allowable line pull of the crane when lifting people. We rig from top down. All right. This next section is rigging math. A lot of this is covered when we cover the rigging triangle. I'm not going to cover all aspects of sling tensions. A lot of that comes into when you do rigging too. But you need to understand we rig from the top down and we center the load over the load's center of gravity, straight in line with the load line. These are weights and measures. Sometimes you have to calculate the square footage, the cubic volume, in order to find the weight of an object. Remember, the lift director is required to, or is to provide the load's weight, but you need to verify the load's weight and its center of gravity. These are how you conduct and can and determine tension factor for loads that are not symmetrical. Coefficient of friction. It's the amount of friction required to slide a load across a surface, whether it be steel, concrete, ice. There's a lot of it's the friction, it's the amount of force required to get it moving, basically. Okay. We're not going to get into the details of all of this. Unless you want to sit down later on, we'll talk about rigging to information. This concludes the rigging. We covered hardware, below the hook lifting devices. We covered miscellaneous hardware, jacks. We covered lifting people, B30.23 and and ASME 1431 cover lifting people. This is what we covered today. This concludes the rigging portions. We'll see you when you have questions later on this week.